speaker is Mr. John Lowe, the director of the Climate Science Department of the National Environment Agency. The NEA, which was formed in 2002, is the leading public organization responsible for improving and sustaining a green environment in Singapore. That's from your website, which also says that you are committed to motivating every individual to take up environmental ownership and to care for the environment as a way of life, which I think is a nice thing to do. Among the many portfolios of the NEA are pollution control, waste management, energy efficiency, and even the control of insect-borne diseases. But Mr. Lowe's division is Meteorological Services, which probably most of you know through their issuing of haze alerts. But it's the leading government science department on the climate change issue, and Mr. Lowe is our one scientist on the panel tonight. So, Mr. Lowe.
Okay, good evening, professors, students. Okay, when I was asked to deliver a talk on this science of climate change and different scenarios, I was thinking, you know, at what perspective should I approach this at, you see. So, because I'm not sure the level of the audience that I'll be talking to, and I understand that there are many professors here that probably are much more well-versed in this topic than I am. So I took a risk and sort of, I'll be talking a bit about the science, but prior to that, maybe I thought I would just give a very short introduction about what we do. As the chairman has mentioned, actually what we do at the Meteorological Service actually is very much different from the rest of the NEA, which are more responsible for, all kinds of operational work. So we are in actually, predicting the weather, providing weather services and climate services. So just a page of a simple diagram that sort of illustrates our customers. Basically the civil aviation, the military, the industries, the public agencies, industries, even like public golf courses, they subscribe to our services. They are quite sensitive to lightning and even marine services. And we are also, since a couple of years ago, we also have taken on new tasks, new roles, such as monitoring the earthquake and tsunamis, and transboundary haze, which we have been doing for quite some time already. In recent years or so, I think two years or 3 years ago, there was this Mount Merapi from Jakarta that erupted. So we also was also involved in trying to monitor and track the dispersion of the volcanic ash cloud in the region. And we were providing our public agencies with maybe necessary, warnings and tracks dispersion forecasts of how the ash could possibly affect Singapore. And most recently, last year, of course, we had this Fukushima incident, and again, our meteorological service was responsible for providing and issuing of possible fallout from Fukushima, which fortunately did not travel that far, and and the other thing that we have also been taking on is also now that the government has identified that we should do a bit more to understand climate change and climate science, and we have been taking on the role as the agency to develop this capability to inform government and through our better understanding of our weather systems in the region, and things like numerical weather prediction, which I will talk very briefly about, and also some of the climate scenarios that is actually part of the topic. Okay, so my talk is as follows. Basically, just the three main topics: the background science, and the evidence of climate change, and lastly, I'll talk about climate scenarios. Okay, so I think basically most of you may a bit, not too sure about the difference between weather and climate. So maybe just to start off the whole thing, I will just explain the basic difference. So when we actually talk about weather, we are referring to the conditions of the atmosphere over a short period of time. And when we do climate, we talk about climate, okay, we are more talking about the average of weather and over a relatively long periods of time. Okay, so then the other thing we probably want to talk about to understand a bit more is so climate variability. Okay, so up and down variations in the climate system, the temperature. Here I show a temperature profile, a temperature chart. You see that there are ups and downs. So those are indications of variability in the climate, and you can see that actually it happens on various time scales. So you can have variability in terms of months, years, decades, centuries, and even millennia. Okay. So when we refer to what is actually a climate change, what do we say? What do we consider a climate change? Scientifically, we refer to it as a statistically significant change in climate characteristics over a period of time. Usually, we would like to say that to have reference to a data of at least 30 years, because anything shorter than that can be misinterpreted. And if you look at this temperature chart here, if you look at, depending on where you would draw a line, a trend line, you can see that it can be a bit deceptive. Depending on where you start drawing a trend line, you can have different kind of trends. So usually when we talk about climate change, we do refer to, at least we have to use a record of at least 30 years or more. Okay, then you can also be even longer. If you have even longer records, then you would be able to define climate change in a clearer context. Okay. Okay. Then what is actually climate change? Okay, some of you probably will be fairly familiar with this. So, in terms of this chart, this graph here, okay, you see that there's a shift in. It can mean a shift in the mean. Okay, where you see that the mean of the mean of the trend actually goes up, okay, over some time. But what it also means is that if you look at the red portion, the red area that is shaded, you can see that the extremes, there are more record hot weather. Okay, even though you just have a shift in the mean, but that would lead to actually a greater occurrence of hot weather, and sometimes we refer to it as more frequent occurrence of extreme weather. Okay, so similarly, you can look at the other charts, which I would just skip here. Okay, so there are various causes for climate variability. Okay, as I mentioned just now, you can range from time scales ranging from a few days all the way to even millennia. Okay, so these are some of the various examples that people have, scientists, researchers have actually discovered. So